Welcome to the demonstration of provenance services with smart data agreements, an ONTOCHAIN OC2 long-term project also known as PS-SDA. The project is led by iGrant.io, supported by My Data Sweden and Linaltech. In this session, we demonstrate how the Data Exchange Agreement Protocol Suite, DEXA, is used to establish an immutable provenance trail during data exchange. The demo covers the following aspects related to data provenance. First, how data sources can prove their legitimate right to process data and share it with third parties. Second, how data using services can ensure that they are on the right side of the law when it comes to consuming personal data. And thirdly, how individuals can have full transparency and control on what data is being shared and how it is used. This slide shows a typical data exchange ecosystem. An agreement that exists between the individual and an organization is called a data agreement, and an agreement to share data between organizations is called a data disclosure agreement. The DEXA protocol holds both types of agreements with embedded provenance metadata. In our demo reference model, we have 4 actors apart from the Ethereum test network: the data source, the data using service, the individual whose data is being transacted, and the data marketplace, where organizations can dynamically share data without a direct relationship. The DEXA protocol is instantiated for all 4 above actors to keep track of the data transactions and signatures anchored in the Ethereum ledger. Now to the demo.
First, a data agreement is created by the data source. This agreement is based on a Data Protection Impact Assessment, or DPIA, to ensure that any data processing is adhering to data regulation. In this example, the data source uses individuals' consent for third-party data sharing. Based on the newly created data agreement, the data source now goes on to create the data disclosure agreement. Once created, the data source publishes this agreement to a data marketplace. Let's now move to the data using service screen. Assuming a data using service is connected to the data marketplace, it can now request a DDA offer from the data source and sign up to consume data from the data source. At this moment, the negotiated data disclosure agreement decentralized identifier is anchored to the Ethereum test network by executing the smart contract. Let's move to the data source screen. Once connected to an individual, the data source issues the data agreement for third-party data sharing. The individual receives a notification from the data source and signs it, agreeing to any third-party data sharing. The decentralized identifier of the data agreement is now anchored to the Ethereum blockchain. Let's move to the data using service screen. The data using service can now pull the data from the data source based on the signed data agreements. When this takes place, the DEXA protocol also registers that transaction to the ledger. Let's now look at what's happening in the data subject screen or the individual. Following a data exchange, a provenance record is created in the individual's data wallet in its data sharing history. The individual is able to see the third parties accessing their personal data, when and for what purpose. They're also able to exercise their rights according to data regulation. With this, we have demonstrated the use of DEXA protocol in a typical data exchange scenario, making data transactions trustworthy, auditable, and immutable. Please do contact us if you wish to know more about adopting DEXA protocol into your centralized and decentralized applications.